Hello, this is the Capstone project for Berkeley's online data strategy course. My name is Eric Anderson, and I'll be applying the data strategy concepts to our organization, which is a congressional committee that was created through the CARES Act in the early days of the pandemic. Our committee is tasked with overseeing the $5 trillion in relief spending with a mission of identifying fraud, waste, abuse, and mismanagement of those funds. But also, as part of our mission, we are to share our data and our findings with other inspection entities in the government. While we're a young organization of almost 3 years old, we're also about midlife or a little past midlife as we're looking to sunset the organization towards the end of the 2024 fiscal year. So that'd be in September of 2025. But in our time, through a combination of both ingestion and generation, we've been able to amass over 6 terabytes of data so far. That began with PPP and idle loan data. We added hotline data, uh, restaurant revitalization fund files, other source files, and augmented it with third-party data. And then we generated volumes of results through geospatial, social networking, address verification, and other machine learning methods. All of this was accomplished through a host of data analytic projects, which resulted in many types of fraud being identified. Perhaps the most common by volume that's been identified was identity theft. Some types were just lying on applications, and some were by individuals, others by organized crime. Obviously, there's different combinations of these that can be true. So you can have organized crime rings doing large volumes of identity theft. While our mission is to find these cases and provide investigative support, we also need to reach out to other agencies and engage them in our knowledge, our processes, and our analytic techniques with the hope of empowering oversight beyond our lifespan. So part of that effort is to educate and empower others. Our leadership has long shared the mantra of if we build it, they will come. The thought being there that if we are able to put together a world-class data analytic environment and show the investigative community what is possible, they'll not only look at our environment as a resource for pandemic fraud detection, but also as an example for what's possible in their world and past or post-pandemic. So our legacy will be having spread data analytic know-how across agencies. As we all know, an ounce of prevention is worth a pound of cure, and that applies very well with fraud. If we can prevent fraud from happening in the first place, we don't have to chase it down later. Every penny that was stolen from pandemic spending was money not spent on people who really needed it. So one of the main goals for this strategy is to provide investigative agencies with tools, data, and skills to take advantage of what we've built, understand how it's applied, and then continue to improve on the capabilities and efficiencies and apply that towards prevention in their own agencies. So while we have already provided a lot of analytic output, this strategic plan, which we're affectionately calling Analytics Squared, looks to perform analytics on our analytic results and also bring additional analytic teams into the fold to understand what we've done, what we've continued to do, and empower them to do their own. So as mentioned, we've created terabytes of analytic results, which by itself can be analyzed to produce a richer understanding of this historic amount of spending. So if we dive in a little bit more, we already have a lot of starting points that are in our favor. We generated this data, so we own it. Um, it's part of our mission to share our data and findings with other investigative agencies. So we also have an existing cloud environment that's tailored for data analytics. Some of the new data points that we have created include fraud type, the location where an individual or entity exists, the fraud amount in dollars, different risk flags on loan records or related to loans, as well as the origination. And this is important as we look to take our findings and recommendations back to establish those preventative measures. To gain more insights, we'll look at doing exploratory analysis. This would be a great opportunity to use a tool like Tableau. We use Power BI that can be put in the hands of decision makers, either with static dashboarding or more powerfully interactive dashboarding to show how data can drive educated decisions. And this overlaps well with our data science and culture slides later on, so we'll see how this all dovetails together. So our existing cloud environment is architected for cleared personnel to access sensitive data. So everything's under one roof. All of our services connect securely with one another, and we can create our output and control its path out of the cloud. But our analytic output can now be used as the raw data used in analytics squared strategy. So we can use the same tools, and based upon a user's group assignment, we can govern what data they can access. So just by creating an analytics squared group in the cloud, we can make use of the same data analytic tools. We use Databricks heavily. We can prevent access to our sensitive data and grant access to this new data set and provide our Power BI access for visualizations and interactive executive analysis. If for some reason we need to link back to our sensitive tables, we can still do that safely. While our data is encrypted at rest, once we grant access to users, right now they'd be able to see everything in the table. We do have the ability to obfuscate data on a per field basis, so that only those with special access would be able to see any PII or PHI attributes. We can see how these ideas start to thread well with one another. Our existing technology stack does not need to change much to accommodate this new strategy. The environment exists already, and it scales well for this new effort. We have an ongoing effort for zero trust architecture, and that's already supported by tools like Purview and Sentinel that can provide some both governance and AI event management, respectively. Our existing analytic tools cover geospatial, social networking. We have OCR, machine learning, natural language processing, and visualizations. But for Analytics Squared, we can just leverage our Databricks and Power BI, our ML and visualization tools with the slight security modifications that we mentioned earlier. So at this point, we know our use case, we know what we want to provide, we have an environment architected for that purpose, and we have tools that can do the job. So now, what will we do with all of that in place? Well, there are two main data science tasks that will help us extract more value from our data. First, with exploratory analysis, thankfully we've created the data, so we already have a good sense of what the data mean. We know what, if any, assumptions were made that sit behind any data points, and we can trace it back to its origin through our extensive data lineage documentation. But what we don't know yet is what we can gain from all this data. We might have some initial questions to answer, like what are the most common fraud types by case number or amount, and we can create some histogram charts for that. We might want to know, are most fraudsters acting in crime syndicates? Are they company entities or individuals? And is there any correlation to the amount of fraud based on each? And so maybe a scatter plot can help us visualize that. And we can also provide some drag and drop functionality for partners and stakeholders to look at our attributes in different ways with different filters to get a better sense of what's happening by location or by amount thresholds, loan type or fraud type. And as new information comes in, such as convictions, we start getting convictions on the cases that we investigate, we can extract even more insights. I believe we already have our location information set up by region, so I don't think we even have to do any transformations coming in. But of course, we would need to review that further if there were any other requirements for it. Going back to a need for preventive measures, we see that predictive modeling can produce a great deal of value. So a model that can identify what fraudulent loan applications look like can be applied to new loan applications in the future and flag them for further review. This might need some refinement as there are loan applications that either vary across organization or over time, but there are enough similarities that this is a powerful next step in preventing fraud. If we couple that with regression analysis that can provide a predictive amount of fraud in dollars based on any new relief packages that Congress may approve, we can start tracking benefits over time. Hopefully, with better and better classification models in place, fraud is reduced, and then we'll start to see these predictive regression models providing lower and lower fraud amounts, and that would reflect success. So a lot of what we already covered helps support this slide, but it's useful again to see how everything ties together. As we line up this data for external access, we can put together the entire data flow and develop some of those histogram and scatter plots we discussed earlier. It's a small lift to put that together and then connect with other inspection offices and not only demonstrate it, but actually give them a login so they can have hands-on access to the data, play with the crosstab report, and understand that their own data scientists can use our data analytic tools and data to gain further insights that are relevant to what they do. So planting those seeds will help spread value through word of mouth. More and more offices will join in, and that we know that there's already an appetite for this within our community. So we definitely want to capitalize on that existing enthusiasm. So wrapping up, our next steps are to firm up the governance of our existing infrastructure to support external users and access our own data and tools. Then we ensure that our metadata from existing analytics gets properly routed to storage that is configured for external access. And then we develop proofs of concept that can be shared with our partners. If we can start conversations early enough, we can even get an idea of what their specific needs are and develop most of what they need for any given simple example. And we can follow this up with workshops and white papers to help them self-service later, but certainly provide that training across a very large community, getting a big bang for the buck. And that concludes this data strategy presentation. Thank you for a great course, and I look forward to any feedback you may have. Take care.